Kernel density estimations. Kernel, now we will learn to density estimations and why these things are actually important to the world of machine learning. So we already know how to draw a histograms, that already we have known. Now for a discrete data we have drawn the histograms. Now from the histograms, that if you are interested to find the probability density function of the from a discrete data sets, so in such cases we need to learn the kernel density estimation. So let's see how these things has been done step by step. That for understanding purpose I am taking this image from the similarly as regular from Wikipedia page. There's just a search on Wikipedia kernel density estimations, then you can easily find this in this image. So let's see step by step. So that's I have taken that from that examples. They have taken the five set of data points and corresponding the histograms of the data point is like that. So this is the first point, this is the second point, this is the third point, this is the fourth, fifth, and this is the sixth. There is sixth point, and corresponding the each point, the histograms are look like this. Okay. Now from this histogram, from these histograms, from these histograms, if we want to find the probability density function, so in such technique we need the kernel density estimation. We need to apply the kernel density estimation that we need to. So let's see how these things. Suppose now first things that we have to do, that's I am using in these examples, they have using the Gaussian functions to estimate the kernel density. And there are various kind of, then just in these examples they have taken the Gaussian functions, and there have also various kind of kernel density techniques, but as an examples for our easy of our understanding, in that I have taken the example that have used the Gaussian for estimation the kernel. Okay, so first that I have to do, so for each data point, we have to draw the Gaussian functions for each data point. Suppose here we have taken here the five set of data points. We have taken here the five set of data points, that is 1, 2, 3. Just it would better I have taken the zooming here, zooming something. Okay, it is 4, it is 5, it is 6. So we have taken the 6 data points. Corresponding the 6 data points, we have drawn the Gaussian functions. This is the first 6th data point, this is for the 5th data point. That Gaussian functions. Now to estimate from these Gaussian functions, we have to estimate this probability density functions that we have to estimate. Okay, now the question is, suppose how estimate these things. Suppose let's take, we have taken a random point x. Here I have taken a random point x here. Now for that random point, we will get that, suppose this is the first point, corresponding to this first point we have drawn the Gaussian curve. Suppose let's take the Gaussian curves that I have used to draw on here. That's the for the first point Gaussian curve. This Gaussian curve for the second point, this Gaussian curve for the third point. Okay, but our point just at this point is our here, but on this point we have the Gaussian curve. Now how to estimate this PDF of on this point? So first we have to sum up the value on this x point, on this point x we have some value on this curve. we have some value on this curve. Just I'm taking different. On this curve we have some value, okay, red. On this curve also they are have on some value on this curve, also they are have some value on this curve. Now at the to find this value on this curve, we have to sum up these three value. We have to sum up these two value to find this estimation point on the probability density function. We have to sum this point. So we have to sum this point. To find the actual, to find some this point, to find the value of this estimation on this point. Okay. Similarly that points also to find these estimations. To if we just interest to find these estimations on that point, means on that point on here, we just find the estimations on that point, then we have to pick these points, means we have to sum up this value means here we have how much curve, 4 points, this value, this value, this value, and also this, like that. Just draw a straight line and just sum up these points to find this point. Okay, so just using these techniques we have to estimate this PTA. Now the question is the H curve that we have drawn here, the H curve that we have drawn here, the H Gaussian curve for corresponding H point that we have drawn, these points are called the kernel. This curve is called the kernel. Okay, and the corresponding for the H kernel, and this is the simple Gaussian kernel. This is the simple Gaussian kernel, and the spread of this kernel, is called the bandwidth in another language, means the variance of this spread are actually depends on the variance, and that things are actually mean. Just remember that if you just remember the Gaussian thing, that things are actually mean. So the mean value lies on the actual point and these things are the depend on the variances of the curve. So this is then another language, these things are called the spread of the Gaussian kernel. Okay, and or another language is depend on our variances. It's depend on the variances of the Gaussian distributions. And another language, these things, this spread in another language, this spread are called the bandwidth. Okay, in another language these things are called the bandwidth. I think you have understand so how these estimations are work actually. Okay, now the band questions is how to select the proper bandwidth. Now the questions is how to select the which are actual, the questions is now the questions is how we select, how how we select the right bandwidth. This is the big questions. How we will select the right bandwidth? Okay, so let's see. Just I am taken the same image. I am taken the image that's from the same site, Wikipedia. That's for the better understanding. So I am little zoom out. Okay, I think this is better. This is better. Let's say these points are the this is a random variable, and this is the our data observations point of this random variable. This is the sample our random variable, and these points, these blue points, I'm taking the similarly. These blue points are our observations. These blue points are our observations. The observations of the random variable x. Okay. Now, just this is the actual, this gray line. These gray line are actual the proper bandwidth, right bandwidth, actual distributions. This gray line. These gray lines are actual distribution. These actual distributions of the observation. These gray lines are the actual distributions. But how we will decide it? Which is our right bandwidth? So to decide it, we have to we have to test various kind of bandwidth. So if we just take on the large bandwidth, so our if you just take on the large bandwidth, suppose if you take on the large bandwidth, then our estimation, then our Gaussian curve will be like that. If you take on the large bandwidth, then our Gaussian curve will be like that, such kind of like that, taken the different color, like kind of. So if you take in the large bandwidth, then the spread of the Gaussian kernels are larger. The spread of the Gaussian kernel larger. If the spread of the Gaussian kernel is larger, then the PDF functions will be, then the main PDF function, then the estimated PDF function must be more or flatter. Okay. So because of that, if we taken the large bandwidth, if we taken a very large bandwidth, then the actual distribution functions will be more flatter. So if you take on the very large bandwidth, then this kind of flatter estimation function. And if we take on the very small large width, if we take on the very small bandwidth, then our estimations for our estimations function will be like zigzag functions. Okay, because of that, because if you taken the small bandwidth, then how look these functions are? These functions are actually look like that. Look like that. And also, if you just close your, if you just close your bandwidth, then its heights are increasing. It's this kind of things. If we taken the closer bandwidth, then our estimation functions, then our Gaussian normal distributions will be like that, like that, like that kind of. If we taken the closer, if you taken the narrow bandwidth, small bandwidth, okay. If you taken the small band, so in such cases, the estimations probability density function, the estimations of the probability function, estimations of the probability density functions will be zigzag type of functions. Because in this kind of things, and if you just at the end of the, if you just sum that, this will be very close, this kind of, so will go. So if you take a very small, if we taken the very small bandwidth, then this kind of functions will go. Okay. And if you just taken an average bandwidth functions, if you taken then some average bandwidth functions, if you taken some average bandwidth functions, then this kind of, means it is a medium kind of band. Medium type of bandwidth functions. If you taken this medium kind of bandwidth function, then the estimations for probability density function estimations are like our actual estimation. So we will see the large type of bandwidth and also very small type of bandwidth will be harmful for us. So we have to choose a median kind of bandwidth to predict the PDF as correct as possible. Okay, so this is the main thing. So for the kernel estimation functions, for the kernel density estimations, for a kernel density estimation, the size of the, so the length means for for kernel for kernel density estimation, for kernel density estimations, or choose the length of the bandwidth. So length of the band width, it will be, it it is a hyperparameter. Okay? It is a hyperparameter. Okay, so we have to choose the right length. So if we choose this very small length, so it will be not a right approximations. As well, if you choose a very large bandwidth length, so this also not be a large parameter. We have to choose this bandwidth length between them. So this is the simple and one kind of hyperparameter. And now we will see how to choose a right parameter. So there are various kind of techniques to choose right parameter. There have the cross validation technique, there have the various random search technique, there have the various kind of technique that we will see in the next part of this lecture series. Okay, that's the main thing. I think that you have understand the kernel density and kernel density estimations concept, and how these things are actually useful to predict the probability density functions from a discrete set of data. Okay, I think you have understand the concept, main concept of it.